Taylor and Jordan are filling up their water bottles at 2 different water dispensers. They're checking to see whose water bottle will fill up first. So our first question is, who started out with more water in their water bottle? How much more? So when we look at our wording, we see that it says who started with. So that tells me that we're looking for the starting point or the initial value. So we want the y-intercept of each of these. And then it asks how much more, and we can subtract once we figure those out. So let's look at our representations. This one is Jordan. This whole table is Jordan. I don't see Taylor anywhere. Taylor's is this equation. The amount of water in Taylor's water bottle, W, is represented by the following equation. And we're going to assume, because it doesn't tell us otherwise, that they are in the same units. All right. So now we need to find the initial value of both. Well, Taylor's is really easy, so I'm going to start with that one. Its initial value is just the +2. Remember that this is y equals mx plus b. If you actually want to write it like that, if you notice that it looks basically the same except the letters are different, you can still treat it the same way. So if you want to write it y equals 3x plus 2, be my guest. That's fine. You can decide to define different variables for this one. So our starting point for Taylor is 2, and our starting point for Jordan, well, I do want to find 0b. And it says the amount of water in Taylor's water bottle, W. I think this is kind of like our x and this is our y. So I need to find when x is 0, what is y. So I'm going to need the slope in order to figure that out. Yay. So we're going to find our change in y over change in x. And our change in y is 4 from 12 to 16. And then our change in x is 2. So change in y over change in x is 4 over 2. Which just equals 2. So we know that it's increasing to y per x, so 2 ounces per minute. Okay, now you can either put this 2 into an equation, or you can choose to just extend your table out to 0. I feel like a lot of my students feel more comfortable with the equation. I'm going to show slowly how I would make a table and I would extend it out. The 2 ounces per minute tells me that the ounces side will go up 2 every time the minute side goes up 1. So I'm going to actually just make a different table. I'm going to put x and y over here. Actually, we want seconds and ounces because that might be a little easier. Seconds and ounces. Okay, and then I want to find 0, and I'm going to put in some numbers before the first number I have. So I know I have 3, and then let's just fill in 4 and then have 5. So I know 3 is 12, and then 5 is 16. If I put in that it goes up 2 ounces after 12, it should work. It goes up 2 and then up 2. Okay, that makes sense. It's going up the same amount each time. So I know I can just add 2 when I move up and it will make sense. Well, when we're going backwards, then I should subtract 2 to keep the pattern. So 12 minus 2 is 10, minus 2 is 8, and then minus 2 is 6. So then hopefully this looks like you're counting to you. 6, 8, 10, 12, 14, 16. The pattern flows. So then this will make sense. It will be 0, 6. So then his starting point was 6. His 0 was 6. So who started out with more water is the question. So Jordan started out with more water. And how much more? He had 6 and Taylor had 2. So he had 4 ounces more. All right, if both water bottles hold 24 ounces, whose water bottle fills up first? Because apparently they're racing. The good thing is we already have Jordan's full at 24 ounces after 9 seconds. So I have that one already. I don't have to find it. Now I need to figure out, I have to figure out Taylor's. So this is when it gives you an X or a Y and it asks for the other one. Whenever you have it asking for a specific number, you can either find it from the representation like I just did, or you can plug it into the equation if you've found one and figure out that. So we're going to do that with Taylor's. We want to have 24 ounces, and my 24 ounces is Y. So I'm going to put in 24 ounces for my Y here. Goodbye, table. Okay, so W, I'm just going to write Y equals 3x plus 2. Y equals 3x plus 2. Okay, so 24 was my Y, equals 3x plus 2, and then solve for x. So I'm going to subtract 2 from each side because you undo addition first. This is 22 equals 3x. And then this is kind of weird because it doesn't end up pretty. So x equals 22 thirds. All we have to know is whose water bottle fills up first. So is 22 thirds going to be bigger or smaller than 9? Well, 21 thirds is 7. So this is like 7 1/3. So we know that the equation, Taylor's water bottle, will fill up first. Ooh, that was a rough one. A lot of your examples will not be that hard. But you can tell that I used the equation, I used the representation that I had, and I used clues in the question to tell if it was asking me for initial value, a rate of change, or if it was asking me for something else. And in this case, it was asking me when I reach a certain Y value. So I had to plug it into my equation. All right, that is all. Good luck.